In this video, I'm going to show you how to solve a system of 3 equations with 3 variables using elimination. So here are my 3 equations. This is equation 1, equation 2, and equation 3. So step 1 is to add 1 and 2, or add 1 and 3, or add 2 and 3. So I'm going to look at my equations, and you have to pick a variable to eliminate. It's up to you to decide which one you think it's easiest to do. In this case, my personal preference is to eliminate z. So I'm going to start by adding equations 1 and 2 in order to eliminate z. So I'm just going to go ahead and put those next to each other. So here's equation 1. Here's equation 2. And the reason I picked equation 1 and 2 is because if I add negative z plus z, those are going to cancel out or eliminate. So let me go ahead and add them together. So I have 2x plus x, which is 3x. Y plus 2y is 3y. The z's eliminate. And this is equal to negative 2 plus 11, which is 9. So now I eliminated z, and this is a new equation, and we'll call it equation 4. So I'm still in step 1. I added 1 and 2. So now it's your choice to do either 1 and 3 or 2 and 3, but you still have to eliminate z in order for the elimination process to work. So in this example, we are going to choose 1 and 3. So I'm going to go ahead and write those next to each other. So there's equation 1. Here's equation 3. Now looking at the z's, I have negative z plus 2z, and if I add those together, that's just going to give me 1z, which does not eliminate. So I have to use a trick. In order to eliminate 2z, I have to have negative 2z. So 2z minus 2z, those would eliminate. Therefore, I need to multiply the first equation by 2, because 2 times negative z gives me negative 2z, which eliminates with the positive 2z. So let me go ahead and distribute the 2. We get 4x plus 2y minus 2z is equal to negative 4. So now I can go ahead and add these together because the z's are going to eliminate. And so let's go ahead and add them together. Negative 2x plus 4x is 2x. Y plus 2y is 3y. The z's eliminate, is equal to 15 minus 4, which is 11. So this is equation 5. Alright, we're ready for step 2. Step 2 is to add 4 and 5. So I'm going to go ahead and write 4 and 5 right next to each other. So 4 is 3x plus 3y is equal to 9. and 5 is 2x plus 3y is equal to 11. And as you can see, this is simply a system of two equations with two variables, which we are really familiar with solving. So in order to solve this, I can see that I have positive 3y and another positive 3y. If I make one of them negative, then the y's are going to eliminate. So I'm going to go ahead and multiply equation 4 with negative 1. So negative 1 times 3x is negative 3x. Negative 1 times 3y is negative 3y. Negative 1 times 9 is negative 9. Let's go ahead and add these together. So we have 2x minus 3x is negative x. The y's eliminate, and this is equal to 2. Now we can go ahead and solve for x. So we divide by negative 1 on both sides, and x is equal to negative 2. Now we're ready for step 3. Substitute x, y, or z. The one you substitute depends on how you began eliminating the system. So we started by eliminating z, and we ended up by solving x. So that means we're going to substitute x into equation 4 or 5. It's up to you to pick which one you want, as long as it's equation 4 and 5. So we're going to pick equation 5, and we're going to substitute negative 2 in for x. Alright, now we can go ahead and solve for y. So 2 times negative 2 is negative 4. We're going to add 4 to both sides. So we get 3y is equal to 15, and y is equal to 5. Finally, since I have x and y, I need to substitute that back into either equations 1, 2, or 3. Let's pick equation 1. And by substituting x and y, I'm able to solve for z. So we're going to substitute negative 2 in for x, and substitute in 5 in for y. Let's go ahead and calculate this. Negative 4 plus 5 is 1. Subtract 1 from both sides. Oops. This is negative 2. Okay, subtract 1 from both sides. We get negative z is equal to negative 3. Divide by negative 1. And z is equal to positive 3. Finally, we need to write the answer as an ordered triple. Negative 2, 5, and 3. So here is the final solution.